Generative adversarial networks are a class of artificial intelligence algorithms that belong to the field of generative modeling. They were introduced by Ian Goodfellow and his colleagues in 2014 and have since become a prominent and influential method in the domain of deep learning and generative AI. GANs consist of two neural networks that are trained simultaneously, the generator and the discriminator. The primary idea behind GANs is to create a system in which the generator network learns to generate realistic data samples, while the discriminator network learns to distinguish between real data and data generated by the generator. Here's how the GAN training process works. Generator. The generator takes random noise as input and attempts to create data samples that resemble the real data distribution. In the context of images, for example, the generator learns to create images that look like real photographs. Discriminator. The discriminator is trained on a dataset containing real samples from the target domain and the generated samples from the generator. It learns to classify between real and fake data samples. The objective of the discriminator is to correctly identify whether an input sample is real or fake. Training process. During training, the generator and the discriminator are alternately updated in a game-like setting. The generator aims to generate more realistic samples that can fool the discriminator, while the discriminator strives to improve its ability to correctly distinguish between real and fake samples. The training process is iterative and adversarial, meaning that the generator and the discriminator continually improve and compete against each other. Over time, the generator gets better at creating more realistic data samples, and the discriminator becomes more discerning in recognizing real data from fake data. Once the GAN is trained, the generator network can be used on its own to create new data samples that resemble the original dataset. GANs have achieved remarkable success in generating realistic images, videos, audio, and text, making them popular for various creative tasks such as image synthesis, video generation, and text-to-image translation. However, it is essential to note that GANs can be challenging to train and require careful tuning to avoid issues like mode collapse and instability during training. Researchers are continuously working to improve the stability and robustness of GANs to make them more practical for a wide range of applications.